Buy it, use it, break it, fix it, trash it, change it, melt, upgrade it, charge it, point it, zoom it, press it, snap it, work it, quick erase it.
With recent advances in genetics and molecular technology, scientists have gained the ability to modify the expression of existing genes in an organism's genome or to insert genes from other organisms' genomes. Many of the modifications that have been done over the past several years have been done with good intentions in mind. For instance, the invention of a vitamin A producing golden rice strain has helped several countries overcome widespread vitamin A deficiencies. Pesticide-resistant strains of crops has also allowed for more efficient farming. However, some of these modifications have led to unforeseen consequences, such as transfers of resistances to unintended organisms. The Monsanto Chemical Company is famous for their resistant crop seeds, but has become known for the unintentional spread of modified genes among crops and other plant life. After years of research, scientists are now able to transfect modified genes to higher organisms. One of the most famous examples of this is the inclusion of bioluminescence genes from jellyfish into a line of cats. Although this gene transferal has no negative impact besides affecting the cat's ability to hunt at night, it opened the door to transferring more functional genes into other organisms. Recently, scientists in Japan have modified major histocompatibility complexes in sheep to express markers that are commonly found in the human body to allow for growth of organs that have significantly lower chance of being rejected in transplants. While the benefits of such technology may seem obvious, we have to begin to wonder if the unforeseen consequences of these modifications will mirror those seen in modified crops. For now, the most hotly debated topic in genetic modification is whether we should be allowed to modify the genes of humans. The possibility of removing oncogenes from our genome, or overexpression of genes that might make people more successful in life, such as the genes for intelligence, memory, or physical modifications like an increased metabolism or a more robust immune system, has made a division in the scientific community. For now, many of the modifications that can be done involve aesthetic traits, which raises several questions in itself.
Dr. Steinberg, he just said that he predicts we will have determined sex with 100% accuracy and eye color with 80% accuracy in the next year. Does that give you pause at all?
It does. I think he's wrong. I don't think we're going to get to eye color and hair color and freckles for a couple more years, but he's right in principle. We're headed that way. It is going to be possible to pick traits not because of diseases or avoiding dysfunction, but because somebody has a taste for a particular child or a preference for a particular child.
He says that if it is available, why not offer it to his patients? He says he has the obligation as a doctor to do so. Do you agree with that?
I disagree completely. There are really three things, Maggie, to think about here. One is, when you move away from diseases, who's to say what's the better trait? Is it better to be redheaded than it is to be brown-haired? Is it better to have freckles or not? Those sorts of things, I think, are very subjective and in some ways driven by our culture. Secondly, you're going to have the rich using these technologies, and that's going to advantage them further. It's not going to be something the poor get to do. Mm-hmm. Lastly, you got a problem here. Why are doctors in this business at all? The doctor said, I have to serve my patients, but is this just a cash business where you'd say, you know, I want a child with short arms, I want a kid with athletic ability? Mm-hmm. Yeah, okay, well, we'll do that. Is everything and anything for sale at the fertility clinic?